Students, welcome back once again to our series of videos on differential equation. We are back with a new part on differential equation. So today we are going to talk about something new, and let's check this color first of all. Yeah, it's okay. So we are going to talk about initial just hold on. Initial and boundary value problems. Very important. Value problems, very important, very important. Okay, so let's start with the first part of this, and the first part is Picard's method. Picard, Picard's method of successive approximation for the existence of solution of IVP. What is IVP? Initial value problem. Okay, the first thing, the method is based on the fact that the function satisfies the initial value problem. Okay, that y of x will satisfy the initial value problem. That means, so let me show you. That means dy by dx will be equal to f of x comma y comma y of a is equal to b on the open interval, of course, L, on the open interval L, right, containing x equal to a if if and only if y of x satisfies yx is equal to b plus integration of a to x f of t comma y of t dt. Alright, now what you need to know from here, of course, for all x belonging to I, alright, if the function y of x satisfies this equation, okay, 1, if y of x is satisfying the equation 1, okay, then clearly y of a is equal to b. Okay, then y of a will be equals to b. Alright, that means by differentiating on both sides you will get dy by dx. So if you differentiate diff on both sides, you will get dy by dx is equal to f of x comma y. Alright, and of course y of a will be equals to. So for solving this equation we will have to, of course, start with y1, right? y1 of x will be b plus integration of a to x f of t comma y0 of t of dt. Right, like that way if you continue on, right, you will have to go on till yn plus 1. If you continue like this, you will go on till yn plus 1, which will be equal to b plus integration a to x f of t comma yn of t dt. Alright, so that's what you will get. And y1, y2, yn is defined for some open interval y1 comma y2 comma y3 right until yn is defined for some open interval, okay, x equal to a. Okay, students, so from here it means that now in the next part, from here it means y of x is equal to limit n tends to infinity yn x exists, alright, exists at each point, of this interval, of the given interval, okay, of the given interval, then it will follow, then it follows that y of x is equal to limit n tends to infinity, alright, yn plus 1 of x is equal to limit n tends to infinity b plus integration a to x, alright, f of t comma yn of t dt. Alright, now you see you'll get many points, many more things over here. There will be many more things. That is actually the evaluation of limits. So eventually, after you get everything, the final proof will come. Y of x will be equal to b plus integration of a to x f of t comma yt dt. Alright, so that finally you will get this, okay. And of course we will have to do one question on this, but we will do in the next video. That's it for this part of Picard solution, and we will continue this in the next videos. So thank you for watching. See you in the next video, students. Bye bye.